Hi, welcome to DevSecCon 24. I'm Rob Richardson. Let's dig into service mesh to service mesh. Before we do so, here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker. So let's head over to robrich.org. We will click on presentations here at the top, and you can see service mesh to service mesh here at the top of the list. You can grab the slides online right now. That's perfect. While you're here at robrich.org, click on About Me, and you'll see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate, a Cyril developer evangelist, and let me tell you about AZ GiveCamp. AZ GiveCamp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your neighborhood, hit me up on email or Twitter, and let's get a GiveCamp installed in your neighborhood too. Some of the other things that I've done, I do a lot of Docker and Kubernetes training, and one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into service mesh to service mesh. Oh, jumping ahead. We talked about this guy. Do you remember the first time you learned to drive? Or the first time you got to travel outside of your town? Do you remember how freeing and exhilarating that was? Seeing the open road, getting to expand your geography? Now, let's imagine this country road where there isn't very much traffic. Well, in time, the town grows up and we end up with something like this. That's pretty crowded. So what can we do about it? Well, let's post a traffic cop right at the edge of town, and anyone who's speeding will stop them and make sure that the traffic is all flowing consistently. Now, on the upside, we don't end up with those traffic jams. On the downside, we're not really getting to where we need to efficiently. We're just all getting there the same. Where we want to go is something like this, where the cars can communicate together. We can create mechanisms where expedited vehicles can move really quickly, and those with more leisurely paces can accomplish that as well. We're not penalizing people and moving them towards conformity, but rather prioritizing and organizing traffic. We'll see similar methodologies as we start looking at service mesh. As we look at service mesh, we're going to define it, we're going to take a look at what makes it great, we're going to look at demos of both Istio and Linkerd, and we'll look at places where you may want to choose something different. Let's dig in. So what is a service mesh? A service mesh manages network traffic between services in a graceful and scalable way. It's the answer to how do I observe, control, or secure communication between my microservices. Now, if I'm inside a Kubernetes cluster, I really do want to be able to observe, secure, and control the content between my services. Let's take a look at that. Observe. My goal with the service mesh is to be able to watch the traffic flowing between my microservices. I want to make sure that the traffic is as I expect. In time, I will create policies that controls that content. I don't want microservices calling into other services that I don't expect. I want to make sure that rogue services aren't able to penetrate the services that I need. And finally, secure. I can create mutual TLS between my services so that other traffic running within my cluster isn't able to see the communication between my microservices. Observe, control, and secure. That's the purpose of service mesh. Well, how did we get here? We started out with a monolith, like this on the left. Now, this monolith was great in being able to deploy infrequently and have all of the content in one place. We got on that call Friday evening after work, and usually by Saturday afternoon, the system was maybe hobbling along again. By Sunday morning, we were exhausted. So what got us to the system on the right? Well, on the right, we have microservices. Deployment was made easier with containers, and we've standardized on Kubernetes as a great way to deploy. Now, this is great. We can deploy a lot easier, maybe dozens or 100 times a week or a day. But on the left, private methods were private. On the right, all of our private methods have a network address. So, as we talk about securing traffic within our cluster, we'll talk about both north-south traffic and east-west traffic. North-south traffic is that traffic flowing into or out of the cluster, where east-west traffic is traffic flowing between microservices. Now, the cool part about a service mesh is we can support both east-west traffic and north-south traffic in our process of observe, secure, and control. So what came before us? Well, an API gateway. An API gateway is like a fence on the outside of our cluster. It's the traffic cop on the edge of town. Now that's great. Any rogue traffic coming into our cluster is blocked at the API gateway. But what about the traffic flowing around within our cluster? Now, one of the tenets of a microservice is it owns its own data. But I've got these other microservices reaching into the data stores. The API gateway has no visibility into that because the API gateway's job is to be the fence around the cluster. All the east-west traffic within the cluster is outside the purview of the API gateway. So we add a service mesh. How does a service mesh work? Well, without a service mesh, service A would just call out to service B. But with the service mesh, there's a few extra steps to get from service A to service B. Deployed with each service is a sidecar proxy. Now this proxy is able to proxy network traffic between services. So service A is going to reach out to its client-side proxy, and this service A proxy will reach out to the service mesh control plane. Am I allowed to talk to service B? In this case, the control plane says yes. So service A's proxy creates a network request to service B's proxy. Again, service B's proxy is going to check with the control plane. Am I allowed to receive connections from service A? In this case, the control plane says yes, and the connection is created. Now, service B's proxy forwards that traffic onto service B. Service B is able to compute that result, and it flows back across the proxy back to service A. That's the methodology of service mesh, where we have these proxies that are able to validate the traffic and ultimately connect to the services that are needful. Now, because we have a proxy across all traffic, we can do really interesting things like observe, control, and secure the traffic going between our containers. Now, the beauty here is that this observe, control, and secure comes with no changes to our application. We'll be able to observe the traffic because, well, it's flowing through this proxy. We'll be able to control it. As it checks in with the service mesh, we can say, nope, I really don't think you ought to be able to connect to that service. Or when receiving inbound traffic, no, I don't think that service should be able to accept this traffic. And then finally, that connection between the services can be secured with mutual TLS using a trust chain from the service mesh. So anyone just wandering through the cluster can't see that traffic. Perfect. Now, a service mesh is more than just a proxy. As we level up in our service mesh, we can take a look at interesting scenarios. First, network topology. Hey, we're watching all of the traffic and all of the network connections between our services. Let's map that out. That is amazing. We can take a look at service health. As we're looking through all of these network connections, we can pay attention to which ones are throwing 500 errors or 404 errors. And finally, log all of that traffic and the health of the services in an interesting way. That's kind of our first level of a service mesh, where we get network topology, service health, and logging. Let's level up a little bit more. We can, since we're taking a look at all of the network traffic, create a circuit breaker. Now, a circuit breaker is a really elegant way to stop network traffic when a service is struggling. Let's imagine that we've overwhelmed the service and it's really struggling to keep up, or maybe it tips over. Now, of course, every dependent service is going to do what they do, assume that it was an intermittent network blip, and retry the connection. So as the service starts to come back up, it gets flooded again and tips over. A circuit breaker is great at standing in the way. It notices that this service is struggling, and it will cut off communication to that service and just fail the request right away. Now, if the client restarts that connection or retries, it will still get that failure. The service is offline. When the service is healthy again, then the circuit breaker connects that content back up automatically and connections start flowing again. Unlike a circuit breaker in your home or business, you don't need to go back to the panel and turn it back on. The service mesh circuit breaker can do this automatically. Now that we've got intelligent routing, we can start to do interesting things like, well, if you're part of this group, I can send you to a different page. So we can do A/B testing, where maybe we'll create two different versions of our service, and we can evaluate how the traffic moves between them. Are customers negatively or positively impacted by this change? And we can create a beta channel or a Canary release, where those users who want to opt into the newest features can go to this new version of the service while regular users go to the regular service. We'll also get dashboards with our service mesh that lets us view health and logging and connection details. What's great about a service mesh is because we're watching both north-south and east-west traffic, we can prevent these types of unexpected connections between things. Which service mesh should I choose? Istio, Linkerd, Console, Open Service Mesh, or others? Instead of comparing the features, let's look specifically at the methodologies because, well, they're all moving really fast and they're all keeping up. Linkerd focuses on being a bare minimum install so that you can get up and running fast. They're really proud of their install experience, and we'll get to see that today. By comparison, Istio is a collection of all kinds of open source packages where you can turn things on and off. Where Linkerd like to write it itself, Istio collects the best of the open source. We can create a profile that turns on and off these various features, and we can enable or disable the various open source packages. So let's take a look at both Istio and Linkerd. We'll start with Linkerd. Let's fire up a Linkerd cluster, and we'll get started with Linkerd. Now, to get started with Linkerd, we come out to the Linkerd Getting Started page, and after downloading the Linkerd installer, we can do Linkerd check -- pre. That helps us identify if the cluster is ready for Linkerd. Once we've got it ready, then we can do a Linkerd install, pipe it to kubectl apply, and then we can do a Linkerd check again. Now, in this case, we're not doing a check -- pre, but rather a check. So I've already installed Linkerd, and let's check to see if it's running. It'll run all of the hooks, and we've got it ready to go. The next step in the installation process is to install the visualizers. Now, this is optional, but let's do it. Linkerd viz install, pipe it to kubectl apply -f Linkerd viz install. There we go. Now it's going to install all of these resources into Kubernetes inside the namespace Linkerd. Kubectl get namespaces, and we'll get kubectl. Typing is not my friend today. There we go. So there's the Linkerd namespace and also the Linkerd viz namespace. Now I am going to pull out this this namespace. So let's say kubectl describe namespace default. And we see that we have an annotation. Oh, it isn't active yet. We'll have an annotation on each namespace that will allow it to be able to proxy that content inside Linkerd. Let's take a look at the Linkerd namespace, and we can see those labels that identify that this will inject the Linkerd sidecar. Okay, Linkerd check. Let's see if the content is ready. Well, it looks like the visualization pieces have installed and we're ready to go. So we can take a look now at the content, Linkerd viz dashboard, and up pops the Linkerd dashboard. Now let's take a look at the Linkerd dashboard. We'll dig into the Linkerd namespace, and we can see the various deployments associated with this. Now each of them come with a Grafana dashboard. So let's pop this one open. Now this Grafana dashboard will show us the various metrics associated with the service. And as you can see, it hasn't been up very long. But I love that we get statistics for this content really easily. Now, this dashboard is great at being able to discover the uptime and the metrics associated with that. But what if I want to do this more from the command line? Okay, let's close down this dashboard and let's close down this, and we can say linkerd viz stat. Now we'll go for the namespace linkerd, and we'll look at deployments. Now here's each of those deployments, their metrics, and we can get that from the command line as well. That's perfect. Whether we're pulling the metrics using Prometheus and Grafana, or whether we're grabbing them from the dashboard or the command line, we can get at linkerd details really easily. Now let's flip over to Istio. Here in Istio, we'll switch over to the Istio cluster, and we can see that we've already got kubectl get all dash namespace Istio. Nope, it's in the regular namespace. Okay, so a similar install experience for Istio. We go download the executable. We can go grab the thing, and then we'll run this Istio install, and then we can set our profile. Which features do we want enabled or disabled? Once we've got that set up, then we can label our particular namespace to be able to create that content. So let's describe that. kubectl describe namespace default. We can see that we have this Istio injection enabled attribute, and so all of the pods that get scheduled inside this namespace will have that Istio sidecar applied. Now let's take a look at a demo. As part of the Istio setup, if you choose to, you can install this sample application. Now this sample application has this product page that gets the product details, and it also has a reviews service. You can use version 1 that has no stars, version 2 that has stars in black color, and version 3 that has stars in red color. For version 2 and version 3, they'll reach out to this rating service to see how many stars they should show. Now right now I have this page up, and I have it rigged to equally go to each of the services. So sometimes we have stars, sometimes we have no stars, sometimes the stars are in black color, sometimes the stars are in red color. Let's take a look at how we built that. Now here's this virtual service that specifies how we should route traffic to each spot. And right now they're even 33%, 33%, and 34% across all of the services. Okay, so let's come into this directory. Book info, networking, and here's all those files. kubectl apply. I'm going to apply this one, the one that always points to version 1. So let's grab that file name, kubectl apply -f, that virtual service. Now with this virtual service, everything goes to version 1. So let's refresh this page, and we'll see that now we never get stars. Okay, I'm ready to deploy version 2. But I'm not quite confident about it. Let's send 80% of the traffic to version 1 and 20% of the traffic to version 2. Let's grab this virtual service, and after we've deployed our pods and we've got them running, we can flip that traffic over to version 2 for 20% of the time. Now let's refresh the service, and sometimes we get the stars in black color, but most of the time we don't get stars. Perfect. We've validated that our service works correctly, so let's switch over to version 2 completely. Now that we've got version 2 running, all of our traffic will go to version 2. Now I want to create a Canary channel. I want to create advanced features, and in this case, I'm going to give the user Jason access to version 3. Now I might choose to do this based on an auth header or based on a URL. So let's flip over to this version. I will create this content, kubectl apply -f there. And now, while unauthenticated, you can see I'm not logged in, I will always get version 2. Now let's log in. I'm going to log in as Jason. And now that I'm logged in, I get the stars in red color, version 3. Log out, and I'm back to version 2. Perfect. So now version 3 looks like it's working and we're ready to release it. Let's switch, oh, that's not right. Let's switch over to version 3 completely. And now we've got our content, and I'll always get version 3. Ooh, did I not apply that correctly? Virtual service reviews. Version 3. There we go. Now I'll always get them in red color. Well, let's go back to our version 33, 33, 33. This one. It's actually 33, 33, 34. Cube CTL apply-f. There we go. And now we're back to the random version that will get us some of each. We saw how we could upgrade across versions, and we didn't need to take down or spin up pods. In this case, we had all 3 pods running at the same time, but you can imagine how as that pod is ready, we spin it up, we smoke test it, and then we start slowly moving traffic over to it. Now, similarly to the dashboards that I saw with Linkerd, let's take a look at some of the dashboards that we can look at with Istio. Istio CTL Dashboard Prometheus. Not Prometheus. Prometheus. Okay, so here's the Prometheus dashboard. Now I can choose Istio requests total, and I can take a look at those requests. Here's each of those requests that came in. Now that might not be a great way to visualize it, so let's upgrade to Grafana, and up pops the Grafana dashboard. Now with Grafana, I can take a look at the dashboards that I have, and let's look for an Istio dashboard. Now these dashboards come built in with the Istio install, and you can see that Istio has been up for a little bit, and I can see some of the traffic coming through. There's no errors, that's great. So that's Grafana. Let's also take a look at Jaeger. Jaeger is really great for tracing. So up pops up the Jaeger dashboard, and now I can get a feel for the services in my system. We can also, inside Jaeger, take a look at the system architecture. The ingress gateway goes to the product page. The product page goes off to the details. And then the product page also goes off to the reviews system and the rating system. Now, this isn't what the developer thought was going to happen. This is what is actually happening inside of the service mesh. That's perfect. Well, what if the reviews service never calls the rating service? Well, I'm probably on an old version of the review service, or maybe I hard-coded the URL somewhere or default values. It's great to be able to see the actual implementation of this content. I'm going to upgrade to Kiali, or not upgrade, but rather switch over to the Kiali dashboard. And the Kiali dashboard is particularly interesting in that we can take a look at the graph of the content happening. Now, right now I don't have any requests, so let's create some requests in our data store. And now the Kiali dashboard should have that content. And now I can see the content moving. Now, in this case, the reviews service goes to the rating service. The product page goes to the product page. It looks like we only got version 1 content. Let's refresh it a few more times. And now we see the actual graph of the system. The product page version 1 goes to the reviews site. That either goes to version 2 or version 3, and that goes to the rating system. Here's the reviews system. It just found that there were some version 1 requests as well. And so we can see how the system works. not the way the developer expected it to work, but the way the service mesh has watched it work. This is ideal. So let's stop that dashboard and flip back over here. We got to see the service mesh. We got to see Linkerd's really elegant spin-up mechanism, and we got to see all of the features, all of the third-party packages that Istio builds in. As we look at service meshes, we can start with just the crawl stage. In the crawl stage, we're just proxying traffic between things. We can monitor things, we can log, we can take a look at service health. Crawl, walk. As we start walking, we can create intelligent routing. We saw how we could create A/B channels where only JSON got the new version. We saw how we could slowly transition traffic from version 1 to version 2, where 80% of the traffic went to the old version and 20% went to the new version. This kind of intelligent routing is possible because we're able to proxy all the traffic. Crawl, walk, run. Now we can take a look at the system. We can see the things that are actually moving between our services, and we can see if that matches what the developer expected. That's perfect. As we look at a service mesh, we can look at these methodologies of being able to not only proxy traffic, but be able to observe, secure, and control that traffic. Now, a service mesh doesn't come for free. In our regular Kubernetes cluster, we had the control plane, we had worker nodes, we had our various pods and services. And with the service mesh, we have the various pods and services associated with the service mesh's control plane. And we have those sidecar proxies. We're pretty much running twice the number of containers in our cluster. So there will definitely be some additional compute cost. Now, granted, that Tomcat service, that container is probably a lot beefier, a lot heavier, a lot slower than this sidecar proxy. So maybe we're not using twice the horsepower. Maybe we're using, 1.6 times the horsepower. But there is a non-trivial amount of additional compute. Now, the sidecar proxy is pretty fast, so there probably won't be a whole lot of latency involved in this experience. But there is a whole lot more compute going on. Expect your cloud bill to go up. A service mesh allows us to observe, control, and secure. We can observe the traffic flowing between our services. We can create policies that control this to only allow traffic in as we expect. And we can secure that traffic using mutual TLS with a trust chain through the control plane. Use a service mesh if you have very high trusted or very low trusted workloads running alongside other workloads. If you need to do PKI or PCI, then you probably want to corner that off into a separate spot. Now, Kubernetes namespaces are great, and they allow us to create policies that only certain users can launch content. But once a container is running inside of Kubernetes, the namespace does not block network traffic between services. A service mesh can create that boundary between the namespaces. Perhaps I have a very untrusted workload. Maybe I'm running a multi-tenant system. In this case, I can create those lanes where a specific tenant only can see and access their own resources. If I need security in depth, a service mesh is a great mechanism for doing that. If I need A/B routing or a beta channel, if I need to observe, secure, or control my traffic, a service mesh can be perfect. A service mesh is great if I have that need to observe, secure, and control my traffic. There is some additional compute cost, but it is a really elegant system. Find me at that place that the conference has designated for Q&A, or if you're watching this later, hit me up on Twitter at rob_rich. You can grab these slides online right now at robrich.org. Thanks for joining us at DevSecCon 24.